Hello, science adventurers, and welcome back to a very special experiment. I know I haven't posted anything for a while because of projects and school and stuff, but one of the reasons I haven't posted anything is because I've been working on this. I know it's really ugly, so ugly that only its mother could love it, but I am its mother, I guess, and I love this thing. I only finished it yesterday. It's a hydrogen generator. You can see I'm using a medicine bottle because it's got this little pop top thing that can pop off if the gas gets inside. Anyways, so it generates hydrogen and oxygen by passing electricity through some water. Interesting thing you can see, if I can get around my tripod, is this side here has rust and this side here doesn't, because one side's being oxidized and the other side's being reduced when you put current through it. So that's something cool. So today I'm going to use this in a cool demonstration to disprove a very common chemistry myth. So while we watch this video of the generator not working, I'll go ahead and explain what the myth is. So the myth is that energy is stored in chemical bonds, and when you break the bonds, you release the energy. Kind of like, imagine if you have a molecule of TNT and you break all the bonds that are in TNT because it's like a nice big molecule, and then it releases all the energy that's stored inside the bonds, which is wrong because you can see clearly that are put in energy to break the bonds of the water and form hydrogen and oxygen gas, which is then going to supposedly be blown into my soap solution. So you can see clearly that the electricity is going in and the bonds are being broken. And then later, when I light the bubbles, I'm putting in a little bit of energy, again, to break the bonds of the H2 and the O2, and it reforms the water molecule, H2O. And that reformation of the bond is what releases the energy. So it's actually the other way around. You put in energy to break a bond, you think about you're pulling two atoms apart, and then the energy is released when your atoms come back together. Again, they're going from a higher energy state, they're more unstable when they're just by themselves, to a lower energy state when they're nice and stable, they're bonded to each other, all the valence electrons are filled up, yada yada yada. So that's the common chemistry myth that we're debunking here. Well, this is really frustrating. I've been trying to run this. I've run this for so long. You can see all this gunk that's been building up. I think that's probably because I've been using baking soda as the electrolyte for this to help the water conduct electricity a little bit better. So looks like it's forming some weird carbonates or whatever. I don't even know, but it's going really slow. I've switched out the power now to my the DC power generator thing, and it's running at 20 volts constantly at whatever amps it is. You can't see that probably. That's close to 8 amps. So I don't know what's wrong with this, but it's not making bubbles. It was working fine yesterday. The solution's getting hot. It's not a solution, but you get the point. It's getting hot. Wait, I'm getting a little something. Come on. Oh, yes, it's making bubbles. It's working. Bubble like your life depends on it. Make more bubbles! Bubbles! Bubbles, I say, bubble! Alright, I'll be back when this is, done. Alright, so I finally got this thing figured out. It's made bubbles, and so that probably was a good sneak peek at why I don't make that many videos, is because some of the things I tried don't work. Anyways, the bubbles are popping. I have my eyes and ears on, as you can see. Pro tip, write your initials on your goggles so everyone knows who you are. And also, the nerdier your goggles look, the safer, because everyone knows that nerdiness is a measure of safety. Anyways, I'm going to pop these bubbles now, so I'm going to light this on fire, and 3, 2, 1. Yeah! Oh, I didn't even get all the bubbles. Come on! Pop. Oh, these ones don't pop. That's strange. Anyways, maybe I'll try that again, because it seems to be working now. Alright, it's looking good. I'm gonna pop it before it gets too big, because I don't want to like explode my house. Here we go! Woo! Yeah! Happy New Year! Who needs to look at fireworks so you can make your own explosions at home, right? Let's do this. I like this. This is a lot of fun. Oh, these ones don't explode. Why do you guys have to be different? Be like these guys. Explosions are fun. Yeah.